This week's episodes were brought to you by the generous support of Andrew Henninger. Hey folks, Quill18 here, and welcome to another Unity program tutorial. We're continuing to work on our base building game, codenamed Project Porcupine. And I hated the last episode. I was really unhappy with actually the way it came out. Surprisingly, there were no negative comments on YouTube, at least at the time that I'm recording this. But I really wasn't pleased with it. I thought it was too rambly, went in weird different directions, and also the code wasn't particularly strong. So a lot of times I like to record these episodes in bulk, at least for one particular topic, and then I often end up re-recording some of the episodes because I'm not happy with it. I figured there's a better way to explain it. And I really wasn't pleased with this one, but I didn't have time to record more than one episode in that one. So I sort of didn't realize how bad it had gone, at least by, my opinion. What I should have said, so I spent a bunch of time rambling about why we're implementing rooms. And what I should have said is, this is very simple. We need to implement rooms because we want to be able to know if a room is enclosed so that we can identify atmospheric pressure in a room. We know that this room is not exposed to a vacuum, therefore it can have air in it. Done. In addition to that, we may use it later on to optimize inventory tracking, job queuing, as well as other pathfinding aspects, but that will be a later thing. The other thing is, in determining whether we can filter to have, when we plop down a new wall, do we have to do a flood fill? And there is a way, quite easily, I believe, and I might be right this one, that we could filter. Basically, if you're placing a piece of furniture down, and there are, a wall creating an enclosing piece of furniture. In this case, let's assume just a wall. If you put down a wall and it has two other wall pieces adjacent to it, including diagonals, that are not touching each other, then it is possible for this to be creating a new room. Whereas in this case, there would be two pieces of a wall. And how could this create a new room? Well, quite clearly, if you had something like this, then this thing here would obviously be creating a room. So that's a case of, it takes at least two, and they have to be not touching, but that can create a wall. Whereas if you see here, if I create a wall here, there's no way that me adding this wall piece here could possibly create a new room. It's just not a possibility. So we can filter for it, but I'm not sure that it's worth the trouble. I think the flood fill is going to be relatively fast enough, and that doing the code to check this sort of thing is probably not worth our trouble right now. We can always optimize it later on, but let's assume we'll always do a flood fill at this point. Boom. Done. Easy explanation. The final thing is actually a unoptimized piece of code that we don't really need to do. So at the end of the last episode, in our room flood fill algorithm, come on, there we go, open. Right over here, the first thing that we do before we start our flood fill is we delete the existing rooms with the logic of, assuming we have an existing room and we're cutting this room in two effectively by placing this new piece of furniture, what we have decided to do is take the existing room and simply delete it and remove it, start the flood fills, and create two brand new rooms. And I think that's still a good way to do it. I think trying to maintain the old room and only creating one new room, I think that would be very tricksy and sloppy and all that. So I think it's still good, but there's an unnecessary step. So first of all, assuming that we're not an outside room, then we delete it. We never delete outside rooms, and in fact, this delete room function, again, double checks that we're not accidentally deleting the outside room, which I think is really, really good. Then what we do is two things, and it doesn't actually matter what order we do things in. So let's actually, I'm just going to shuffle this around. The first thing it does is remove this room from our rooms list. And this is really good, and we have to do that. The next thing is all tiles that belong to this room should be assigned to the outside. And this, I think, is a completely unnecessary step. This happens in room, and all it does is it loops through every tiles in an existing room, and it assigns them to the outside. And then it resets up its list over here so that this room now has an empty list of tiles. And what should happen at this point is it should mean that the existing room no longer has any tiles. It has no tiles pointing to it. It's no longer in the list. Really, there should be nothing left in the game that is pointing to this room, and therefore it will get garbage collected at some point. And that is still something that we need to do. And later on, if our job system and our inventory system points to a room, we'll have to tie that all into here to make sure things get cleared up properly. But here's the thing. When we do our flood fill, at the end of our flood fill, every tile is going to get assigned to a new room anyway. Either one of the two new rooms that we create, or if if we access vacuum at this point, right? If we busted a hole in our wall, then it's going to be assigned to outside. So this assignment is going to effectively happen twice when we start our room fill. So it's completely unnecessary. I think. Now my problem is, logically, when you say delete room, it makes sense that we should unassign all tiles. But I don't think there's going to be any situation whatsoever where we are deleting a room that we aren't immediately going to be doing a flood fill, which will assign all the tiles to a new room anyway. So I think what we have to do is just change this logic. Or maybe what I'll do, oh, here's a good idea. Or is it? We could delete room after we're done our flood fill. I mean, it's still this unassign all tiles either doesn't have to, it can't run, or at that point we have to make sure that that list of tiles is empty. Just to make this step basically go fast. And maybe that's the way to do it. Actually, that might be the best way to keep this function logical. I mean, I could also put in a thing of like a boolean here of like skip unassignment. So when we do our flood fill, we set this to true, and then we don't do this unassign all tile thing because it's assumed it's going to happen anyway. But let's just change our code around. Let's have this deletion step be last. And I think that's actually pretty fair. And really what we're going to do is we are going to, and I've been saying we're going to create 2 new rooms, actually. Well, I guess that's always going to be the case. We're never going to create more than 2 rooms with that. With this, well, that's not true. Actually, we can create 3 or even 4 rooms. Again, it's very easy to imagine that if we hit load here. And again, it's mostly that that diagonals example, right? You could easily end up in a situation where you have a big string of diagonals, sort of like this. Oops, that didn't line up quite right. There we go. Something more like that. And like that. So we're going to go from 1 room to 4 different rooms can all happen. So, really, this do room flood fill, I think actually we might call it a sub function in here to do it. We're still not going to go recursive because recursion can lead. Probably we have plenty of stack space here in our Unity C# program, but sometimes it can be really tricksy until you really know your environment. And maybe I don't know how the stack space compares between running this on a PC versus running a WebGL version, which runs in JavaScript, versus running things on a mobile device. So we're not going to use a recursive option. But what we are going to do is we are going to keep a reference to the old room. Okay, old room over here is our source furniture's tiles current room, because we know we're going to have to delete it at the end. So if old room is not equal that, then we delete room, old room. And as we go, when we assign tiles to a new room, we should remove that tile from the list of old room or something like that. That way, by the end of it, this will be effectively null. Or we can manually force it, right? Something like this, dot tiles equals new list tiles. That might be the best way to do it. Right. We know all tiles now point to another room, so we can just force the old room's tiles list to be blank. That way, when we run delete room, it's not going to go and do a bunch of weird reallocations on tiles, which honestly now don't even belong to this room. And so, because delete room points all the tiles to outside, but at this point, all those tiles should be pointing somewhere else anyway. All right, so we're going to go ahead and do that. That's going to be okay. And then what we're going to do is, I guess we will call another function. All right. Try building a new room starting from the north. And then we'll have, so this has been a public function. We're going to have a, I guess, protected static void function, which is the actual flood fill. So actual flood fill. I mean, terrible name. Maybe I'll come up with something else after. But we're going to change things up. So do flood fill starts from the furniture that started all of the trouble. And then after that, we are going to do the actual flood fill starting from a tile. So we're going to do, first we're going to have to assume the tile is correct. So if our source furniture dot tile, I wonder, it might be handy to have like a north tile function, because we do this a lot, right? So what I was going to do is say like, oh, world.getTile, where the x is equal to the same and the y is equal to 1 bigger. Why don't I just create a little function in tile? Yeah, I should have done this ages ago, because that's going to save us a lot of little writing of code. So in tile, we're going to create public. It returns a tile. It's just going to be called, I don't know, north? Yeah, that seems pretty straightforward. So it's just going to return the world.getTileAt, where the x is the same and the y is 1 bigger. Of course, this could return null, and that's perfectly fine. Right? It'll return null if we were already at the edge of the map. South, east, west. Yeah, I should have done this ages ago. So that's at y minus 1. These two y's are the same, but it's x plus 1, not 21, or x minus 1. Lovely. Okay. So if our tile dot north not equals null, then what we do is we call actual flood fill. We're going to need some extra parameters here, but we call it with the tile. And I think we call it with the old room. Well, we definitely call it with the old room. The question is, do we also call it with the new room at this point? No, I think we can create the new room in actual flood fill over here. Okay, and again, I hate this name. Do room flood fill, and then actual flood fill. Maybe do room flood fill from tile, or flood fill tile. I don't know, something of that nature. I'm not happy with that naming scheme. It's such an insignificant little thing, but these little things sometimes bother me. So we're going to do that, and we're going to pass it the old room in there. Because now the actual flood fill works like this. First of all, if our starting tile is not equal to old room, because it's easy to imagine. So, right, we're going to do this 3 times, 4 times, 5 times, no. East and west. And then we're just going to pass those. Actually, I guess I could save this. Hold on. I mean, I've already done the typing. But we could do this. We could do this. And then here, the first thing we could do is if tile is equal to null, then we are trying to flood fill off the map. So just return without doing anything. There we go. So we just return. We could throw up an error or whatever, but we know that that's going to be a case. Sometimes we have plopped down a piece of furniture, a wall, on the most, north, east, south, west, whatever edge of the map, and that will mean that one of its neighbors will be null, and we just check for that, and we return, and that's okay. It is a perfectly legal move to do. Although, in actual game interface, what we might do is make it so the player can't actually build right to the edge of the map, which is very common. I don't know about, Prison Architect, but Dwarf Fortress, certainly, and RimWorld, I believe they both have a border at the edge of the map that you can't build to. That way, this will actually never come up in practice, but, we'll check. So, if we're trying to flood fill off the map, we just return. Next, if tile.room is not equal to old room, then this tile was already assigned to another new room, which means that the direction picked isn't isolated. So we can just return without creating a new room. Boom. So we just return again. So again, what does this mean? This is in the situation where we hit new and we hit load, let's say. What kind of example can we come up with this? Can I come up with an example for this? Oh, yes. So if we have wall... Oh, build a wall. If we have walls that look like this... I should increase the speed for testing. There we go. And then I build a wall here. What's going to happen, we're going to try to do a flood fill from the north, which is going to generate a big room over here. Then at some point, we're going to try to start a flood fill to the west. But this western tile already is not going to be part of the old room. It's part of the new room that we got when we flood filled to the north. So we know that west has already been handled. So again, we can return instantly. If we get to this point, then we know that we need to create a new room. I'm actually lying to you. Create a new room. There's actually one more test. Because, oh, I should have left that example up. Because, if I go and build a little bit of a wall here. Oh, come on, build wall. Right? The other thing we haven't checked yet is here when we check the east. Well, we don't have to do a flood fill to the east because there's a wall there. So, the other option is if tile dot furniture dot enclosable. I guess that's the function that we're using, right? Is in place furniture. We're starting this whole flood fill. Is as the furniture is of type room enclosure. So we've got to check to see if the tile we're trying to build in has a piece of furniture that is a room enclosure, then obviously that we can't be flood filling room from here. So if tile.furniture is not equal null, and tile.furniture dot in room enclosure, this tile has a wall, door, whatever in it. So clearly we can't do room here. So again, we return. But there we go. Once those three criteria have been checked for, then we know we've got an empty tile that is still pointing to the old room, which is obsolete. Therefore, we have to start our flood fill. Okay, and then we can start our actual functions. So first of all, what we need is we need to create a new room. That seems pretty good. So we'll call it new room. I like it. Equals new room, and room doesn't take any parameters or anything like that. That's great. And the new room has a list of tiles, right? We've got new room.tiles. This is the list of tiles that belongs to this new room. This should be instantiated by our constructor, and it is right there. Tiles equals new list of tiles. Great. So we have an empty list of tiles ready to be filled with the new ones. So we're going to start with, well, I guess with ourselves, right? Yeah, sure. We'll start with the current tile. The current tile clearly belongs to this new room. Do we have like an add room tile or something? Oh yeah, we have assign tile. Great. So new room dot assign tile. So our current tile, which is just called tile. Yes. Okay, good. And assign tile. Let me double check. Assigns the room's tile to be this and adds that room to our list of tiles. Beautiful. So we assign ourselves. Then what we have to do is we have to keep checking all of our neighbors. Right, actually, we don't have to... Ooh, yeah, we do need another empty list. Yeah, I guess so. So rather than assign the tile right away, let's back up a step here. We're going to create a new list of tiles. Tiles to check, which most flood fill algorithms might call this Q. But we're going to make a new list of tiles. And instead of adding our tile directly to new room, we're going to add our tiles to this. Tiles to check dot add, and we're going to add our starting tile to that. And then we're going to loop while tiles to check dot count, I guess, is greater than 0. And what we're going to do is we're going to grab the first element, which I guess could be a Q. That's probably a lot faster. Yeah. Q. Make this a Q and a Q. Well, I guess it doesn't really matter, but it's a Q is optimized to add things to it and remove things from it. Whoops. Can you add? No, it's in Q. There we go. So, tile T equals tiles to check dot DQ. And then we can so that removes that tile from the list, and then we can check first, okay, if t.room is not, or is equal to old room. So this is a room we actually have to process. So first what we do is then we say new room dot assign tile t. Then we queue up our 4 neighbors. So we add, well, we add our neighbors if they're not walls, really. Oh, we can move some of these checks. Okay, let's assume we're just going to add all 4 neighbors to start off with. So we're going to say, so we know that this room, this tile that we're looking at, was still pointing to the old room. So we can assign it, but then we have to check all of its neighbors. So we're going to go ahead and add in our north, south, east, west neighbors. Assuming they're not null, and at this point we really probably should check for that. No, it's fine. So we've got a tile.north. I go northeast, southwest, I suppose. I mean, we're not really being consistent. North, south, east, west is a nice way to say it, but I tend to write things as N-E-S-W because we go sort of clockwise. It really makes no difference whatsoever. So we're going to do that. I don't know. You know what looks better? That looks better just because it's got a 5-letter word followed by 4-letter words. Makes no difference whatsoever. So we're going to queue those up, and then we're going to keep looping. And so on the next go through, so we have just set our tile to be part of the new room. Then we can queue everything. On the next go through this while loop, we're going to grab, well, basically our northern neighbor, and we're going to check to see if it was assigned to the old room. If it was, then we assign this one to the new room, and then we keep going. Eventually this has to stop right now, though, right? Because right now we're just going to queue up every single neighbor forever. Plus, so there's things that should stop this. First of all, what if one of these tiles is actually a wall? Well, then obviously we don't want to start adding it to the thing. Secondly, these tiles we know could be null, right? Right. So instead of checking over here, we could just blindly add this tile to the queue and then check over here. Because ultimately, we're going to have to either not in-queue a tile because it is the wrong type of tile, or in the loop, we can do the check. I guess if we check before in queuing, it's slightly more optimal because we're not going to queue a bunch of nulls or a bunch of like dummy things, so it'll use slightly less memory. I think the processing time, the CPU time, will be effectively the same in our algorithm, but we'll save a little bit of operation within the queue. Okay, it was going to be really cool and sexy if I could just like take all of this and move it inside of our loop. And it would be really sexy to do it in there. But I don't know. Because right now we'd have to do all the checks all 4 times. So we have to check if north is not null and if north is... we don't have to check whether north is in the old room or not. Although we can, because maybe it's already been processed. So we could check all those things here. All right, so if t.north is not equal null and t.north... And I mean, we could cache a copy of this, but this t.north function is going to be really, really, really fast. So I don't think it's the end of the world. We can see. If we need to start optimizing things, we can go and grab a copy of that. And maybe, I don't know, maybe we do. Tile n, or t2, because we can just keep reassigning t2. So t2 is equal to t.north. And then if t2 not equals null, and t2.room is equal to the old room, and t2.room.furniture. Oh, t2, sorry, dot furniture is equal to null. Either it has no furniture, or t2.furniture.room enclosure is equal to false. So either it doesn't have a furniture, or the furniture that it has doesn't cause room enclosure. Well, then in that case, we can go and add t2 to the queue. And then we can just repeat this. I mean, you could sort of make this into a loop where t2 gets assigned from a list of neighbors. Hey, we have that. Because we can get a list of neighbors. Get neighbors. With diagonal OK being false. Okay. Tile array ends is equal to t dot get neighbors. I think the neighbors can have null bits in them, and that is true. So now instead we list for each tile t2 in ends in our neighbors, then we loop through here. There we go. That's a little bit cleaner. And then, yeah, it's not too bad. We make sure, again, that the neighbor's not null. We make sure that the neighbor is actually still part of the old room and therefore hasn't been processed yet, right? We haven't come around to a tile that we've already checked and we're going to start checking it all over again. That would be bad. And we make sure either it's got no furniture in it or that the furniture does not cause room enclosure, in which case we enqueue T2. There we go. That would have been a mistake before. We enqueue T2 in there. All right. And conveniently, this also, has an easy update. If we decide that those little diagonal cracks between walls are legal ways to form rooms, we can always change this to be true to allow diagonals. But in this case, that's going to be that. So this should go through everything. Cool. And actually, I should do the exact same thing here. Right? I mean, the north, south, east, west helpers are still really good. Try building new room. Try building new rooms for each of our northeast, southwest directions. So all we do is we say for each tile t in tile dot get. Oops. Tile dot get. What? Oh, right. We don't have a tile. Source furniture dot tile dot get neighbors. And then we can just say flood fill t. Like that, and like that. There we go. Already better. So we're going to check each of our 4 neighbors and try to do a flood fill from there by passing it the old room. So this is going to create a new room. We're assigning tiles to this new room, which is great. When this is done, tell the world that a new room has been formed. And we know for sure, at this point, that this new room has at least one tile, because we do check here, like we enqueue one tile, and the only way this one tile could not get assigned to a new room, which is here, is if that one tile was not part of the old room. But we've already checked that here and returned early. So the only way we can have a new room created is here, and that room will always have at least one tile in it. So yeah, we can tell the world. And I don't think we've got a function for that, right? If I just check like room, get outside room, delete room. So public void add room r. And we just go, because rooms dot add r. Because I think rooms is private or protected, or it should be. It's actually public. Do we really want that? F it. Let's say that it's fine, but let's still use this function here for now. Again, we'll hopefully be doing we'll probably do an episode at some point that is just going through and doing a code cleanup. We've done that before. It's like, every dozen episodes or so, we should just do a code cleanup refactor episode. Okay, so how do we tell the world? Well, we've got a tile which has a world. So add room, new room has been added there. Excellent. So we're gonna do that and we're gonna return. And we're going to do that for all 4 directions. So now, are we there? And then the old room, we tell it you don't have any tiles anymore. And then we tell the world to remove that. Although, what if it's an outside room? Then we've just told the outside that it doesn't have a tile anymore? That makes no sense. Makes no sense at all. Right. So we were unassigning the tiles here, but only, we never, even before, we were never removing the tiles from the list of the outside room. Now, one thing is we could have our outside room just be null, right? And right now, very logically, if the outside room was simply null, that would keep things very simple. And we obviously don't need to keep track of air pressure in the outside room. But later on, we might want to be able to do a quick check of anything that happens to be floating in space, in which case I want that stuff to belong to the outside room. So this is a no-go. So instead, and while this is slightly less ideal than just doing that reassignment there, when we assign a room to a tile, we're gonna check to see. We're gonna remove it from its old list, from its old room. So if t.room not equals null, right? This tile already in this room. Then we say for the old room, t.room.tiles.remove t. So we remove the tile from its old room. So we know it's not in our room. It's in, and here it belongs to some other room. Belongs to some other room. We remove it from that room's list of tiles, and then we add it over here. So by doing this, and it's a little slower than just being able to bulk write, new list. But by doing this, it ensures that as soon as the room gets assigned to or as soon as the tile gets assigned to a new room, it's removed from the old room, which means that if the old room was outside, well, we've already removed those tiles from outside, which is good because we don't actually ever delete outside. And yeah, unassign all tiles. This doesn't actually do that. It doesn't reassign tiles to the old room. At this point, old room shouldn't have any more tiles left in it. So in practice, this delete room should be pretty instant. It should mostly only need to remove the room from the world's list. All right. What we could do here is we can do a check. Let's do a confirm. If old room, so we know it's not outside. So if old room dot tiles dot count is greater than 0, we're going to catch a bug. Debug.log error. Old room still has tiles assigned to it. This is clearly wrong. Is it possible, if this fired, is this possible that the room with or the piece of furniture, yeah, any room enclosure tiles shouldn't belong to a room. And right now I think that's exactly what would happen. I think our one tile, where we just put down our wall, would still belong to the old room, when it should belong to nothing. So I think what we should do here is say old room dot, ooh, that's interesting. Because it's like source furniture dot tile dot room is now, we should set it to null, I assume. That's the one case where a tile's room will be null, is when it has a piece of tile of wall or of room enclosing furniture in it. Because a wall is going to border 2 different rooms, or maybe even up to 4 rooms, but the wall doesn't belong to any of them. So that tile has to be removed. And that wall doesn't count as being part of outside either, because that wouldn't logically make any sense, I don't think. So that tile has to be set to null, which is quite interesting. And then before we did, well, so we set that, and then we need to also make sure to tell old room dot tiles dot remove, source furniture dot tile. And now I believe this should indeed report 0 for anything that's other than outside, because the outside room is the exception. It could still have tiles left, but we're checking for that here. Okay, let's see exactly how many disasters we've gone and inflicted on ourselves here. Probably a lot. And we actually don't currently get any feedback for whether we've done something successfully, but let's go ahead and try anyway. So if I go and do this, it should not create any rooms. Okay, it's actually generating an error, which is okay. Tile instance not set to an instance of an object. Oh, I need to enclose this here because it's not doing the Boolean check correctly. This has got to be one check, whereas we check to see if it's null, and then we do the OR, but without the parentheses, I think it was still trying to run this bit here, even when it was completely inappropriate. So let's try that again. Hit play. Do we ever assign all the tiles to the outside? That's a question. All right. I was gonna say that took a really long time. Did you see that? I clicked, he got there, he finished the job, and then all of a sudden nothing's happening for a while. It took longer than expected to build a wall. And I realized why. Our flood spill has to bail and change its mind if it hits an empty tile. If it hits vacuum, we have to bail out of this early. Because right now, it's assigning all 10,000 tiles to a room. And it's actually creating a room instead of being outside. So that's actually something we have to fix right away. If we hit a tile that is empty, not a floor, but empty itself, then clearly we are exposed to the outside. And actually, if a tile returns null, that is also a clue that we've hit the edge of the map. So if one of our neighbors is null, then that is the outside of the map, which must be a vacuum. Right. Right. So it's almost like here, if tile.type is equal to tiletype.empty, or, well, I guess it's fine. Here we don't enqueue any nulls. Or one of its neighbors is a null, basically, is what it comes down to. I guess what I'll do is the same thing up here. Well, I'll do a check up here. If tile.type is tile.empty, then this tile is empty space and must remain part of the outside. And I think in this case we would just return for this first bit, because the assumption, the only time this could happen is the situation where I am dropping a tile here, right? And when we're doing the actual flood fill called for north, right, it's going to be calling the northern neighbor right up here, which is an empty. So we're going to notice this is empty, and we're just going to do nothing because that tile will already have been part of outside. So that's fine. We can just return right away. The question is more like, once we've set up a room like this in each one of these little builds, it's going to pause the game and cause things to become unresponsive because we're doing infinite flood filling of the entire map. Oof. But it's more the case when we fill in this wall, this neighbor is going to be fine. So this is not empty, so it's going to run not empty. But then within this loop here, one of these neighbors will have, will either be null if we're on the edge of the screen, or we also have to check that it's empty. So let's do another check here. Before we do this, let's do a check. If t2 is equal to null, or t2.type is equal to tiletype.empty, we have hit open space either by being the edge of the map or being an empty tile, because that's the only reason that one of the neighbors should return null, is if it's literally the edge of the map. So this room we're building is actually part of the outside. Therefore, we can immediately end the flood fill, which otherwise would take ages, right? And we could see, I mean, it's not ages. To process all 10,000 tiles, it still takes under a second to do it. But obviously, that's still not good in the game. So we do want to stop looping through this algorithm. But more importantly, we need to tell all of the tiles in new room, but more importantly, we need to delete this new room and reassign all the tiles to outside. Which, as luck would have it, is exactly what the unassign all function does. Right? If we say new room dot unassign all tiles, unassign all tiles sends them back to empty, to the outside, which is good. And then we can just return this function. So unassign all tiles and return. Now, there's a bit of duplication in that we start the flood fill, we assign them all to a new room, and then at some point we're like, whoa, 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 stop, and then we assign them all to another room, which is the outside room, and then we bail. But I'm not sure if there's a way to avoid that behavior. I mean, I guess we could pre-check all the tiles before assigning anything, or do another list. But either way, you have to keep track of a list of the tiles that may potentially. And I guess that's it. This new room is like a potential room. I could have called it new potential room, and the tiles that get assigned to it are potentially going to be part of this new room, or this whole thing might fail, in which case the tiles actually get dumped to outside, which is what this does. I think this is probably as fine as it is. Technically, we could eliminate this little null check here, because we know T2 is not null. That check is really fast, but I guess what the hell, we'll do it. So at this point, we know T2 is not null, nor is it an empty tile. So just make sure it hasn't already been processed and isn't a wall type tile. Okay, let's try that again. Hit stop, play, build floor like that. Build wall in the top corner. This happens back to normal speed again, which is great. And we can go ahead and do this. Now, we're not getting any feedback as to whether this is working or not yet. Right? But we're not getting any errors, which is a nice sign. So in theory, we now have, well, 2 rooms in our world's room list. In theory, we have still the outside room, which is always at index 0. But now we have another room that is in here at index 1. We're not going to care about the indexes, but that room list in world should have 2 entries. 1 outside, 1 inside. I like how it's got, like, randomly my computer decided to do the thinking icon. If we do this, it should remove the that room from here, from the world list, and instead create 2 new rooms in there. We don't know if that's happening yet because we don't have the debug info to confirm or deny it. And I could just put some debug.logs or something, but what I'm going to do is we're going to put a cut in here. Next episode, we're going to work on adding tooltips to the game because the tooltips are going to be used for all kinds of really handy dandy debug information. Instead of spamming the log and then commenting out the stuff that spams the log, we're going to add a tooltip that when we mouse over a tile, it's going to give us information about that tile. What's the tile type? What's the furniture in it, if any, and what's it called, and also if it's part of a room, and in which case, what is the room index in the world of this, just so we can differentiate. So we should be able to mouse over here, see 0, mouse over here and see 1, for example, and mouse over here and see 2, and if we mouse over the wall bits, it should say that, room null. There should not be a room for the tiles that make up the wall. I don't know if that's true yet, without, I can't confirm. I can't tell you if this code is working correctly yet. So in the comments, if you have pointed something out, feel free to let people know. But try not to be too nasty about me. I don't know if this works yet, and I will be recording the next video immediately after this one. So I should be catching any bugs by virtue of the fact that, well, clearly my next video things are going to go badly, which is always a lot of fun. Thanks for watching, folks. See you next time. Thank you to everyone who pledged to support this in February and is making these videos happen through March and early April. And of course, these Mic Check supporters. We've got Wes Eldenboving again, Craig Mortel, Nail Vikstrom, Neil Blakely Milner, Speedy Savant, Valent Cake Fiend, Aaron Toyson, Marius Field Vold, Ole Peter, Talgo, probably Ole, Julian Ogier, Lafone, Steven Stager, Michael McClintock, Kale the Quick, Drazion, Bite Rash, Adjective, and Andrew Henninger. And everyone who just watches and shares and favorites and comments and subscribes, thank you so much for just continuing to make these videos a thing that we can do. I think it's pretty awesome, and I hope you do too. See you next time, folks.